3 kilogram ball is accelerated from rest to a speed of 10 meters per second. A. What is the ball's change in momentum? B. What is the impulse? And C. If a constant force of 40 newtons is applied to change the momentum, how long does the force act? Well, let's solve A first. What is the ball's change in momentum? We know a couple things right off the top. We know that mass is 3 kilograms. We know that velocity initial is 0 because it's at rest, meters per second. We know that velocity final equals 10 meters per second. And we are asked to figure out what its change in momentum or change in rho is. And that is, the units are kilograms times meters per second. The equation that I will use is I will choose the change in momentum equals mass times velocity final minus velocity initial. So now let's replace numbers for letters. I have change in momentum equals 3 times 10 minus 0. So the change in momentum equals 3 times 10. So the change in momentum equals 30. Now apply the units, kilograms times meters per second. And this is the correct answer for A. Now actually, solve for B is very, very easy because impulse is the same thing as delta P or delta rho, change in momentum. So therefore, impulse equals 30 kilograms times meters per second. So that solves for A and B. Well, let's go solve for C now. If a constant force of 40 newtons is applied to the change in momentum in this situation, how long does it act? Well, considering that we just learned in the very first A and B, our change in momentum is 30 kilograms times meters per second. And we are applying a force of 40 newtons. We are looking for a time, and that's going to be in seconds. And so I'm going to choose the change in momentum equals force times time. Now if I replace numbers for letters, change in momentum equals 30. Force equals 40 times time. To get t all by itself on the right hand side, I'll divide by 40 on both sides. This cancels. This leaves me with t equals 0.75 and apply the units seconds. That is the correct answer for C.